Hello everyone, welcome to IB Math Solution. Now we have studied about sets. Today we'll start a new topic, Venn diagrams, and we'll see how we represent sets in the form of Venn diagrams. So let's get started. So when we say set, every set can be represented as a Venn diagram. And to do so, let me show you how. So we know a set is also a part of a universal set. Therefore, let's first draw the universal set. Suppose this rectangular box is a universal set. Now this set A, let's say set A is a part of this universal set. Therefore, we can say in terms of Venn diagrams, this is set A, which is completely inside this U. When we talk about subsets, let's say a subset B is a subset of A. How will we draw this? B is a subset and it is a subset of A. So to draw this, let's draw the universal set. So we know this is our universal set and this was our A. This is A, set A. Now set B is a subset of A. That means every element of B is also an element of A. So B will be completely inside A. Therefore, B will look like this. This is set B and it is a subset of A. So A has to be a bigger circle around B. And A has to be inside U. That is universal set. Now let's talk about intersecting sets. Let's say A and B are intersecting sets. So first we draw a universal set. This is our universal set and it is denoted by U. Now our A is a set inside this universal set. This is A. And our B is also a part of this universal set but also intersects this A. This is B. Now we know A and B share a common area, which is this part. Now this part over here is what we call A intersection B. And sets A and B are called intersecting sets. Now we know this circle is A, this circle is B, this middle part is A intersection B, and this part, let's take a different color. And this green dotted part, this green dotted dashed area is called A union B. Once again, This circle is A. This circle is B. This common part between A and B is called A intersection B. And this whole part covered by these two circles is called A union B. Now let's move on to the disjoint or mutually exclusive sets. So let's first draw our universal set. This is U. We know this is A. This is set A. And this is set B. Now, there are only two possibilities when we have set A and set B. Either these two sets will intersect each other or they will not. In case of intersection, we get this middle part which is shared by both. This is A intersection B. And we get one whole part. This is called A union B. The second possibility is when these two sets do not share any common part. It means in this case A intersection B is an empty set, or we can write it like this. An empty set is which does not have anything, and in this case we can also say that A union B is A plus B. However, we cannot say the same in this set. Here A union B, in this case A union B will be A plus B, but we know A is this whole part which contains this as well, and B is this whole part which contains this as well. Therefore, if we add A and B, we add this part twice, but we must have this part only once. In that case, we need to subtract this part. Therefore, in this case, A union B is A plus B minus A intersection B. Now, let's move on to exercise 2F and solve some questions. Part A says U, that is universal set, is 2, 3, 4, 5, 6, 7. A is 2, 4, 6, and B is 5 and 7. Now first let's draw a universal set. So this is U. Now A is a circle. This is A. We also know we have B, which is this circle. Now to represent these sets on a Venn diagram, we first need to calculate A intersection B. So A intersection B will be, we know 2 is not present in B, 4 is not present in B, 6 is also not present in B. Therefore, A intersection B is an empty set, or this. Therefore, can we say that A and B intersect each other? No. A and B don't intersect or don't overlap. So, can we say this diagram is correct? No, this diagram is not correct. Therefore, we need to redraw it. And to redraw, we need to make something like non-overlapping circles. So this is B, this is A. Now the elements of A are 2, 4 and 6. The elements of B are 5 and 7. So what are the elements that are left from the universal set that we have not considered yet? 2 we have taken, 4 we have taken, 6 we have taken, 5 we have taken, 7 we have taken. There is only one element, 3, that has not been considered anywhere yet. And this element 3 will be a part of the universal set, but not a part of either A or B. Therefore, this 3 will come here, outside these circles. So this is our Venn diagram. Let's move on to the next subpart. Let's draw the universal set. So this is our universal set. Now first we need to calculate A intersection B. So A intersection B will be 2 is not a part of B, 3 is a part of B, so we'll take 3, and 7 is not a part of B. Therefore, A intersection B will be 3. Now we know we have something in A intersection B, therefore we can say sets A and B will overlap. Hence, we can draw accordingly. So this will be A, and this is going to be set B. Now we know the common part is this one. Therefore, we can write A intersection B over here. Now, set A has 3 elements, 2, 3 and 7. 3 we have already considered. The remaining are 2 and 7. So, we'll write 2 and 7 outside this common part but inside A. And in set B, we have 3, 5 and 11. We know we have already written 3 inside B, 5 and 11 remain. So 5 and 11 will come outside the common part but inside B. And also for this universal set, we know we have taken 2, we have taken it, 3 already considered, 7, 5 is not considered yet, 7 is considered, 3 is again considered already, 5 is also considered, 11 we have considered it, 13 remains. 13 has not been considered anywhere, so 13 will come inside this universal set but outside set A and B. Therefore 13 will come over here. This part is also complete. Now part C and D are similar questions, so this is your homework. I'll move on to the next question. Suppose U, that is universal set, is a set of all integers between 1 and 10 containing both. So we can write U is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now set A is a set of odd numbers less than 10. That will be 1, 3, 5, 7 and 9. And set B is a set of prime numbers less than 10. That is going to be 2, 3, 5 and 7. Now the question is asking list sets A and B. So we have already done part A. Now part B, find A intersection B and A union B. So A intersection B is going to be the common part from A and B. So 2 is not present in A, 3 is present in A, 5 is present in A, 7 is present in A. Therefore, A intersection B is 3, 5 and 7. A union B will be everything in A and B written only once. Therefore, 1, 3, 5, 7, 9 and 2. This is A union B. So we have done this, we have done this. Now part C, represent the sets A and B on a Venn diagram. So first we'll draw a universal set. This is U. Now we know we have A intersection B and it is not an empty set. Therefore A and B will overlap. A is going to look like this and B is going to look like this. We know A intersection B is 3, 5 and 7. We also know A has 5 elements, out of which 3 we have already written inside A. The remaining are 1 and 9. So we'll write 1 and 9 inside A but outside this common part. Therefore 1 and 9 will come over here. Similarly, set B has 4 elements, out of which 3 we have already written. The remaining one, that is 2, will write inside B but outside this common part. That is going to be here. Now for the universal set, we know that out of the elements of the universal set, we have considered 1, 2, 3, 4 has not been considered, 5, 6 has not been considered, 7, 8 has not been considered, 9 is here, 10 has not been considered. Therefore, outside set A and B and inside this universal set U, we'll write 4, 6, 8 and 10. Suppose U, that is universal set, is a set of all integers between 1 and 9. That is going to be 1, 2, 3, 4, 5, 6, 7, 8 and 9. A is a set containing factors of 6. That is going to be 1, 2, 3 and 6. B is a set containing factors of 9. That is going to be 1, 3 and 9. Now the question is asking list sets A and B. So we have done this part already. Part B says find A intersection B. Now as we have listed all the sets, this question, this part and this part you can do on your own as we have done in the previous questions. This is your homework. Let's move on to the next question. Suppose U, that is universal set, is a set of even numbers between 0 and 30. So U is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26 and 28. P is a set containing multiples of 4 less than 30. So P will be 4, 8, 12, 16, 20, 24, and 28. And Q is a set containing multiples of 6 less than 30. So that is going to be 6, 12, 18, 24. Now part A says list P and Q. So we have done this part. Part B is again asking the same questions as we have done already. So B and C is your homework. Let's move on to the next question. U, that is universal set, is a set of all positive integers less than or equal to 30. So that will be 1, 2, 3, 4, and so on till 26, 27, 28, 29, and 30. R is a set of prime numbers less than 30. That will be 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. S is a set of composites less than 30. So S will be 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25, 26, 27, and 28. Part A says list R and S. We have done it. Now as we have listed all the sets, we can do this and this. It is your homework. Let's move on to the next question. Suppose U, that is universal set, is a set of all real numbers. Copy the Venn diagram and label the sets Q, Z, and N. Now we know R is real numbers. Q is rational numbers. Z is integers. And N is natural numbers. Now from here, can we write the elements of all these numbers? We'll try. So real numbers will be everything. Integers will be starting from negative infinity to -3, -2, -1, 0, 1, 2, 3, and so on till positive infinity. And natural numbers is written like 0, 1, 2, 3, 4, and so on till infinity. Now, rational numbers is remaining. So, can we say rational numbers is of the form P divided by Q? Rational numbers is also of the form 1.03, 2.129, 3.1150. So all the terminating decimal numbers can be represented as rational numbers, and all the numbers in P divided by Q form can also be represented as rational numbers, where P and Q both are integers. Therefore, we can say all the natural numbers and all the integers can be a part of Q. But Q also contains other numbers apart from Z or N, and those numbers will be of these forms, either P by Q or decimal form. Therefore, under R we have Q. So this bigger circle is Q. And in this Q, we know N is a subset of Z. Therefore, this is N and it is a subset of Z. Z is a subset of Q and Q is a subset of R. Now the question says, copy the Venn diagram and label the sets Q, Z and N. So we have labeled Q, Z and N. Shade the region representing Q prime, that will be not Q. So Q prime will be this area. Place these numbers on the Venn diagram. So 7, 7 is a natural number. It is also an integer. It can also be represented as a rational number. 1 by 5, we know this is not a natural number. This is not an integer. So 1 by 5 will come inside this circle. 2.8 bar, that will also come inside this circle. Minus pi. Now we know pi is an irrational number. Therefore, pi will be in this shaded part, or negative pi. 0. 0 is a natural number, so 0 will come here. Under root 7. Square root of 7 is an irrational number, so this will also come with pi. Negative 2. Negative 2, we know it's not a natural number, so it will come here. Negative 0.35. This is a rational number, so it will come inside Q, negative 0.35. Let's move on to the next question. Display on a Venn diagram U, that is universal set. So let's draw a universal set. Parallelograms. So we know what are parallelograms. Parallelograms are those four-sided shapes whose opposite sides are parallel to each other. So for example, this is a parallelogram. This is a parallelogram, or rather a rectangle. A rectangle is also a parallelogram. This is a square. Its opposite sides are parallel, so this is also a parallelogram. So, and a rhombus. Its opposite sides are parallel, therefore a rhombus is also a parallelogram. Now the question says rectangles and squares. We know all squares are rectangles. Therefore, this is rectangle and this will be the set squares. All squares are rectangles, but all rectangles are not squares. Part B says U, that is universal set, is a set of polygons. So U is a set of polygons. Q is a set of quadrilaterals. So we know a polygon is any closed shape. So any closed shape is a polygon. This is also a polygon. A triangle is also a polygon. A square is also a polygon. A rectangle is also a polygon. A parallelogram is also a polygon. A six-sided closed shape, that is a hexagon, is also a polygon. A septagon is a polygon. So any number of sides can be called a polygon. So quadrilaterals are those polygons which have four sides, and triangles are those polygons which have three sides. So can we say that quadrilaterals will not overlap the triangles, because a polygon can only have either three sides or four sides or any number of sides, but a single polygon cannot have three and four both number of sides, right? Therefore they will not intersect each other, they will not overlap each other. So this is our answer. Let's move on to the next question. Now list the elements of set A. So we know A contains B, D, E and H. B, D, E and H. Set B contains E, H, F, I and J. E, H, F, I and J. Now A prime is everything other than A. So A prime or A complement will be A, C, K, G, F, I and J. A, C, K, G, F, I and J. B prime or B complement will be everything apart from B. So that will be A, C, K, G, B and D. A, C, K, G, B and D. A intersection B is going to be E and H. A union B is going to be B, D, E, H, F, I and J. B, D, E, H, F, I and J. G, A union B whole complement. Therefore, A union B is this part. So the complement will be everything apart from this. That is going to be A, C, K and G. A complement intersection B complement. So what is A complement? We first need to write A complement, or rather we have already written it here, and B complement, it is written here. Now the intersection of A complement and B complement will be A is common in both, C is common, K is common, G is common, Fi and J are not present. Therefore, it is going to be A C, K, and G. A complement union B complement, that is going to be all the elements from this set and this set written only once, that is A, C, K, G, F, I, J, B, and D. Let's move on to the next question. This Venn diagram consists of three overlapping circles A, B, and C. List the letters in set A. So that is going to be H, J, B, A, D, and C. Set B will be C, D, A, F, E, G, and K. Similarly, C is going to be B, A, F, E, I, and L. A intersection B is going to be C, D, and A. A union B is going to be H, J, B, C, D, A, F, E, G, and K. B intersection C is going to be A, F, and E. A intersection B intersection C is going to be A. A union B union C is going to be everything in this red borderline. So that is going to be A, B, C, D, E, F, G, H, I, J, K, L, show that A union B union C is going to be equal to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in A intersection C minus number of elements in B intersection C plus number of elements in A intersection B intersection C. So let's write it. So number of elements in A union B union C is going to be all the elements, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is going to be 12. Number of elements in A will be 1, 2, 3, 4, 5, 6. Number of elements in B is going to be 1, 2, 3, 4, 5, 6, 7. Number of elements in C is going to be 1, 2, 3, 4, 5, 6. Number of elements in A intersection B, that is 1, 2, and 3. Number of elements in A intersection C, that is 1 and 2. Number of elements in B intersection C, that is going to be 1, 2, 3. Plus number of elements in A intersection B intersection C, that is this part. So only one element. Now the negative numbers add up to 3, 3, and 2, that is negative 8. Negative 8, and positive numbers add up to 20. So 20 minus 8 is 12. Hence the left hand side is equal to the right hand side. Hence shown. Let's move on to the next question. Suppose universal set is a set of all positive integers between 40 and 60 containing both of them. So let's write U, that is universal set, is 40, 41, 42, and so on till 58, 59, and 60. A is a set of multiples of 2. So A, now the most important thing is when we have a universal set, so every other set in that question will take a lower limit of this and an upper limit of this. So A is a set of multiples of 2, so A will not start from 2, A will start from 40. Therefore, this is going to be 40, 42, 44, 46, and so on till 56, 58, and 60. Set B is a set of multiples of 3. Therefore, it will also start from 40 and end at 60. So this will be 42, 45, 48, 51, 54, 57, and 60. And C is a set containing multiples of 5. So it will start from 40, 45, 50, 55, and 60. Display the elements of these sets using a Venn diagram. So this is the Venn diagram. Now we have to show all the elements. Firstly, we need to calculate the set A intersection B intersection C. So is 40 present in both of them? No. Is 45 present in all of them in A, B, and C? No. Is 50 present? No. Is 55 present? No. Is 60 present in all of them? Yes, 60 is present in all of the three sets. Therefore, A intersection B intersection C will be a set containing the element 60, and we can write 60 over here. Now we need to calculate A intersection B. So it will be 42 is present here, 45 is not, 48 is going to be present here, 54 is going to be present here, and 60. So A intersection B is going to be 42, 48, 54, and 60. Therefore, in A intersection B, which is this part, we have already written 60 over here. So the remaining 3 will go in this part. So 42, 48, and 54 will be here. Similarly, B intersection C will be 40 is not present here, 45 is, 50 is not present here, 55 is not present here, and 60 is present here. Therefore, B intersection C is a set containing 45 and 60. So B intersection C, which is this part, contains 45 and 60, of which 60 we have already written, so 45 will come here. Now A intersection C will be what is present in both of them. 45 is not present here, 50 is going to be present here, 55 is not present, 60 is present here. So this is a set of 3 elements, 40, 50, and 60. Now we know A intersection C is this part. And 60 we have already written, so the remaining two, 40 and 50, will come here. Now we'll move to set A. Now set A, out of the elements of set A, we have already written this many elements. So it starts at 40. 40 is written, 42 is written, 44 is not written, so 44 will come here. 46, 48 is written, 50, 52 will come, 54 is written already, 56 will come here, 58 will be written over here, 60 we have already written. Now for set B, we have 42, 45 and multiples of 3. So 42 we have already written, 45 we have already written, 48 we have already written, 51 is not written, so 51 will come here, 54 we have already written, 57 will come here, and 60 we have already written. Now set C, 40 we have already written in set C, 45 we have already written, 50 yes, 55 is not written, so 55 will come, and then 60 we have already written. Now from this universal set, the elements that are not present in this part will come outside this part in this rectangle. So let's write them. So our universal set starts from 40. 40 we have written, 41 no, so 41 will come, 42 is here, 43 will come, 44, 45, 46, 47, 47 will come, 48 is here, 49 will come, 50, 51, 52, 53 will come, 54 is here, 55 is here, 56 is here, 57 is here, 58 is here, 59 will come, and 60 is here. So this is our answer. Let's move on to the next question. On separate Venn diagrams, shade regions for A. So the region for A will be part B says A complement. So A complement will be part C says A intersection B. So that will be this part. Part D says A intersection B prime. So we know what is B prime. B prime is everything outside this circle. And what is A? A is this. So the part common in outside this circle, and that is in A, will be this part. This is A intersection B complement. Part E says A complement union B. So A complement will be everything outside this circle. So A complement union B will be everything outside this along with this part. Therefore, everything out of this part will be A complement union B. So which is going to be this part. Part F says A union B complement. So B complement is everything outside this circle and A is this part. So A union B complement will be everything outside this part. That is this part. Part G says A intersection B complement of whole thing. So we know A intersection B is this, and outside this is the part the question is asking. So it will be everything outside this part. H says A union B, the complement of whole thing. A union B is this part. So our shaded region will be outside this part, which is this part. Let's move on to the next question. Suppose A and B are two disjoint sets. Shade on separate Venn diagrams. So this is part A. Shaded region. Part A says shade the region of set A. This is set A. Shade the region of set B. This is the region. Shade the region of A complement. So everything outside A will be this region. Part D says B complement. B complement will be part E says A intersection B. So there will be no part in A intersection B. So there is nothing to shade. Part F says A union B. A union B will be A and B together. Part G says A complement intersection B. So A complement is outside A intersection with B. So that will be this part, just B. A union B complement. A union B complement, that is everything outside set B. So this will be this part. Part I says A intersection B whole complement. A intersection B, there is nothing in A intersection B, therefore the complement of it will be everything. Let's move on to the next question. Suppose B is a subset of A, shade on separate Venn diagrams. Set A is this. Part B says set B is going to be this. Part C says A complement will be everything outside A. Part D says B complement will be everything outside B. Part E says A intersection B. So A intersection B will be this part. Part F says A union B. A union B will be this. Part G says A complement intersection B. A complement intersection B. So outside A there is no part which comes under B. Therefore nothing will be shaded. Part H says A union B complement. Therefore A union B complement. The part of A and B complement together. So what is B complement? B complement is everything outside this circle, which is this whole part outside this circle, and A is inside this circle, so everything will be shaded. Part I says complement of A intersection B. So A intersection B is this circle and its complement will be outside this circle. Let's move on to the next question. Set A. Set A is going to be this set. Set B complement will be everything outside B. Set B intersection C is going to be set A union B will be set A intersection B intersection C is going to be this part. Set A union B union C is going to be part G. A intersection B intersection C, the complement of this thing. So A intersection B intersection C is this part. Now we have to take its complement. So complement will be everything except this part. Therefore H is A union B intersection C. So A union B is this part and intersection C. So the intersection will be of this part. Hence this part will be shaded. Part I says B intersection C union A. B intersection C, which is this part, union A. So A is this part. So everything in this shaded region is what we are talking about. A complement intersection B union C. So B union C is this part. And intersection with A complement will be, so the part of A complement will be everything outside this circle. So it will contain this part. This is our answer. That's it for today. I'll see you in the next session.